Hi everyone, welcome to this new lecture of hydraulic machines. In this lecture, we'll solve a problem on jet propulsion of ships for both conditions. So both condition in the sense, we know that we are having two conditions of jet propulsion of ships. First one is we know that when the water is entering to the ship from both of the sides, like from the side, the water is supposed to enter to the ship. And the second condition is when the jet is moving and the water is to enter in the same direction to the ship. So these are the two conditions are there, and these two conditions also given in the question. So first one is the water enters through the inlet in the side of the ship. This is one condition. Second condition is the water enters through the inlet facing the direction of motion of ships. That means at which direction the ship is moving in the same like through this point the water is entering to the ship. So this is the two conditions are there. So previously also we have solved some problem, but they, in that time we have taken only individual conditions. So here I have taken two different conditions in same problem. So the problem here I have taken a jet propelled ship is moving with a speed of 18 km per hour in seawater. So the jet propelled ship, so ship is moving with some speed in the seawater. The absolute velocity of jet is 2.5 meter per second, and resistance to the motion of the ship is 25 kilonewton. If the efficiency of the pump which drives the ship is 75%, and the frictional loss of head in inlet and ejecting pipe is 2.8 meter of water. Find the power required to drive the pump. Okay, we need to find out the power required to drive the pump when these are the two conditions are there. First condition is this one and second condition is this. So for this we need to solve this problem. So first of all we'll write the data given in this question. So here only we need to find out the power for two conditions. So first of all, let's see what are the data given. Few data are not given directly, like indirect data are given. So resistance of motion and only ship speed given, then frictional loss and efficiency pump given. So many more data is required from this. Let's see how we can solve this. So first of all, in the first line, you can see that speed of ship is given. So we can write this is speed of ship. So speed of ship we can mention this is small u as a notation, and this is 18 kilometer per hour. And this one we can convert into meter per second because other terms are there in the meter per second. You can see here meter is there and here meter per second is there. So let's convert into meter per second. So 18 kilometer. So 1 kilometer equal to 1000 meter. So we can write 18 into 1000 and hour. 1 hour is given. So 1 hour we can write this is 60 minute and 1 minute 60 second. We can convert in this way, and this cancel this one, and 6 the 3 and 3 again 2 will be over here. So finally we got here this is 5 meter per second. This is the velocity of the ship or speed of the ship, you can say. Now the next one is given absolute velocity of jet. The second one is you can write this is absolute velocity of jet. This one we can mark it, this is V, and the value of this is given, this is 2.5 meter per second. And the next one is the resistance to the motion of the ship is given 25 kilonewton. So resistance of the ship of the motion we can mark it here actually. Let's write down this is resistance to the motion. Resistance to the motion of ship. This one we just will mark it with R, and this is given 25 kilonewton, and this also you can convert into Newton, like 25 into 10 to the power 3 this much Newton. And the resistance to the motion of the ship is equal to the force exerted by the jet. Okay, so here also you can write this is equal to force exerted by the jet. Okay, because we know that when the ship is moving, okay, when the ship is suppose moving in this direction and this is given to this motion, one resistance is opposing here, and that resistance value is given, which is nothing but the force which is exerted by the jet. Because when the ship is moving in this direction, you take this is just this kind of is there, ship is moving in this direction, and we know that the jet is coming out in the opposite direction with a velocity v, and the force which is exerted by this jet, that will be equal to this, okay, equal to the resistance of this one. Okay, that's why I written the force exerted by the jet will be equal to the resistance to the motion of the ship. Okay, next is given efficiency of the pump given. This is efficiency of pump, we can write this one. This is 75%, and this one we can convert into 0.75. Along with that, the frictional loss also given. The frictional, this one we can write. This is frictional loss of head. Frictional loss of head. We can mark it this one. Suppose let mark it HF. Okay, and this one we can write. This is 2.8 meter of water. So these are the data are given in the question. Now we need to find out the first terminology I'll consider. We need to find out the power when the water enters. You can write the first one is the water enters at the side, enters from the side of the ship, from the side. This is the first condition. It is given. So to solve this one, to find out the power, we require to calculate the force. Okay, so before calculating the force, so terminologies are there that we need to understand. So see, we know that the force, actually if I write the formula, the force formula, we know that F equal to, we have calculated in our last lecture. If I'll write this one, let me write the formula so that we can understand what we require. Rho A, and this is VR into V. If you see our previous lecture, there I have written this one, and this also we can write in this way. Rho A, VR is nothing but relative velocity, because when the jet also moving and ship also moving, we need to consider the relative velocity. So here in place of VR, I can write V plus U, which is nothing but jet velocity and velocity of ship into V. So this is the formula. Now you can see in this formula how many terminologies is there. One is density, density of water, we know that is 1000, you can put it, and area of the jet is not given because diameter is not given, so area cannot be calculated, and velocity, and this velocity, the speed of the ship is already given, so we can find out from here. Now if I write this term in terms of mass of water, then I could have calculated differently. So let's see what are the terminologies there. Why I said this one initially, because in the question, if you see, diameter is not given, correct? Diameter is not given, so we cannot, if this is not given, so we cannot calculate about the area cannot be calculated. So what I'll do, so let's find out the mass of water, which is coming out from the jet. So let's find out the mass of water, or we can say the weight of water also can be considered. The mass of water which is coming out, from jet. Okay, that we can find out. So we can calculate the force exerted by the jet. So that should be, see, the force exerted by the jet, as I told you, that should be equal to the resistance to the motion. Already have written here. Okay, so the ship is moving this one, so we have calculated already 5 meters per second. So we can write, okay, the net force, we can write in one more terminology, the net force acting on the ship, will be equal to 0. So why I have written this one, because I have told this force and resistance term here. So what I can say, what are the net force which is acting on the ship? One is the force exerted by the jet, another one is the resistance to the motion. So this one force is there, and this is another one force which is acting on the ship, that should be equal to 0. So here I can write this is if I write the net force equal to 0, then this one also I can write F minus R. Okay, so here I can write this is F equal to R. So already I have written this one here, F equal to R, the same terminology, and from here I can confirm it this one. So we can write this is this one, the value of like 25,000 Newton. So here I have already mentioned that one. Okay, this is not that much difficulty to understand. Now the next term is we need to find out this terminology. As I told you that area is not given, not able to calculate. So we can go for the mass of water. Okay, so what I'll write here, from this force equation, what I can write, this rho AV, this rho AVR, I can what I have mentioned here, relative velocity. On behalf of this, again I can write this one. This is M. This is M. I can calculate. I can write M. M equal to, I know that. Here you can write M equal to rho A VR. V, or you can write here VR also. So this is the terminology. So I can put the value of rho A VR equal to M here, so that I can calculate the value of M, because force is given and velocity also given. Now this one I can write force equal to M into V. So you can calculate the value of mass. So mass of water, we can write force equal to how much? 25,000. Okay, and divided by what is the value of V? V is given, velocity of jet is given. This is 2.5 meter per second. Here it is given. Now if I calculate this one, we'll get something like 10,000. Okay, 10,000. So this much what? This much kg mass of water. Now if this one, if I want to convert in terms of weight, okay, what is the weight of the fluid or water? So this equal to, I can write M into G. Okay, so M value already I have calculated here. This is 10,000, and into G, this is nothing but 9.81. So if I calculate this one, I can write this is 98,000. 30 will be there, 98,100. Yeah, this much Newton. Okay, so now we can see up to this, I hope you understand. The next terminology, we need to find out the power. So before going to calculate the power, we need to know what is the input was supplied and what is the output we have received from the pump or from the ship, we can say. So I'll go for the next page. Yeah, so first let's find out. Okay, let me write efficiency term also. Yeah, efficiency is given. Let me write here, efficiency one term is there. That is nothing but we can write this is output and divided by input. So this terminology will be helpful in future. So I'm writing this one. Now the output of the pump, it should be given by the jet of a relative velocity. Okay, the output of the pump, that should be give the jet a relative velocity, and which will help to overcome the pipe losses. What are the losses are there, that will be helpful. So we can write, let me write here, the output of the pump, or we can say the total energy required, or I can say the total energy required to supplied by the pump. Total energy which is required, to the supplied by the pump. So this one, output of the pump is E, or you can say the total energy required to the supplied by the pump. This equal to I can write what is the kinetic energy of the jet, plus what are the losses happened during this flow, or we can say the power required to overcome the pipe losses. Losses is there, that was given, but how much power required to overcome this losses? So we can write this is power required to overcome the losses, because some losses are happening, that was given in the question. So how we can find out this output of the pump, or we can say what is the total energy required to the supplied by the pump, okay, which is supplied by the pump actually. This one we can write which is supplied by the pump. So how we can calculate this one? Now by adding these two terminology, one is kinetic energy of the pump, another one is power required to overcome the losses. So this terminology we can write, let me write here, So kinetic energy of the jet, which is nothing but we can write this is half mv square. So in place of v, we can write this is vr square, and plus this is power required to overcome the losses. So power to overcome the losses, we can write this is w, and what is the losses is there, that is hf. Okay, now here w equal to weight of water which is coming out from the jet, that already we have calculated. Okay, so this one I can write here, and see w, you know that w equal to mg, already have calculated the value also, and m is the mass of water, which already also we have calculated. Now you can just put the value. Output of the pump, you can write here, let me write output of pump, let me write, so half into mv square, m equal to, already we got here 10 to the power 4 into this is 7.5 square. Yeah, VR actually I have forgot to inform you here. Actually VR is nothing but the relative velocity. VR equal to relative velocity. So how we can calculate this on VR? Now 5 here plus 2.5. So how this one we got here 5 plus 2.5? That also I'll tell you. This is relative velocity. So how to calculate the relative velocity between two body when it is moving in the same direction, or we can say one is moving in this direction, another one moving other direction. If this is the condition, then what I can write? Now this is suppose v and this is suppose u. Then I can write v minus u, because both are moving in the same direction. So the relative velocity of body A with respect to body B equal to this one minus this. We can go. Now when the body is moving, suppose A body is moving in this direction and B body is moving in the reverse direction. This is u. For this condition, what I should write? Now B minus of u, because it is moving in the reverse direction. So what I'll get? B plus u. Okay, this is the relative velocity. So it's the same thing here, relative velocity. That it is in my mind already. That's why I've written that 7.5 directly here VR, because I need to inform you the starting itself. Anyway, so this is VR square, that is relative velocity, plus the w value already we have calculated. So that one also you can write. This is 98,000 something is there. So I'll write directly this one. And what is the value of HF? HF is nothing but 2.8. Okay, so this one output of the pump, Newton meter per second, we can write. Now we need to solve this actually. Yeah, take the help of this calculator. 10 to the 4, that means 10,000, and multiply, this is 7.5 square, yeah, divided by 2. So this is 2,81,250. So 2,81,250. This is one term, plus this is another one term is there. So actually, let me check it once how much we got. Yeah, 9.81 into 10,000. So this is 98. Yeah, 9800. Yeah, this one. This is yeah, this is 9.81 into 10.4 actually. If you see previously, yeah, 9.81 into 10.4. That I have written 98,100. So anyway, so let's calculate this. Okay, this plus, I'll start the bracket here. So what are the terminologies there? 9.81 into 2.8 into 10,000. Bracket close. 274,680. 274,680 equal to this one. So I can write 274,680. If you both what we have added, how much we got? 555,930. Yeah, 555,930. So this much we got here. This much what? Newton. No, this is Newton meter per second. Okay, and same thing I can write, or watt also we can write. And if you want to convert into kilowatt, you can write in this way, like 555 point, this is 93 kilowatt. Okay, this is output of the pump. Now we need to find out the power required to drive the pump, which is actually the power required which is drive the pump, that will be equal to the input of the pump. So how much input we are giving, that we can write input of the pump. So we know that in efficiency equal to this one, output by input, and here we can write power required to drive the pump, which equal to, we can write what is the input of the pump which is given. Based on that, how much power is required, that we can say, like based on this will be equal. So input of the pump, where you can calculate, from this we can calculate. Now if efficiency, I know the value, that is 0.75, and here I got here, this is 55593, this is the output of the pump, and here input of the pump I can write, input of pump I can write. Now from here I can calculate what is the input of the pump by dividing this 555.93 divided by this is 0.75. Okay, so now what value we got here, we'll divide 1000, again we divide how much, 0.75, so 741.24. so here how much we got, 741.24. so this much, okay, this much input of the pump. Okay, so input of the pump is nothing but what I can say, that much power is required. Okay, so this is the first one. First we have calculated for the first conditions, power required of the pump, which is nothing but the input of the pump which is given. Now the second case, it was given, the second case was given what, when the water is entering to the sieve, when water enters through the inlet, facing to the direction of the motion, facing direction of motion, that is same direction, like the ship is moving in the same direction, in the same inlet the water is entering. Okay, so for this condition we need to think in different way. First condition is, let me show you here what is this condition. Actually see, now the ship is moving in this direction, so the water also enter will be through this one. For this condition, the water entering through this side one, and here it is, pump is established here, and the jet of water is coming out from here, and the ship is moving. This is first condition. The second condition is, let me do it here. So second condition is, the ship is like, suppose this way it is there, and it is moving in this direction, the ship is moving this direction u, and through this direction here orifice is there, and through this orifice of inlet the water is coming inside, and here it is leaving out, and here pump is there. This is the movement. So for this condition we need to find out what is the power required to drive. So for this condition, if you see, when the water enters the facing the direction of motion, obviously it possesses some kinetic energy. So this kinetic energy of this water, so that will be equal to the velocity of the motion of the ship, because this velocity and this velocity both are same. So we can write what is the kinetic energy of the fluid which is coming inside, it will be equal to the velocity of the moving ship. Okay, so the energy required to the supplied pump, okay, the energy required to the supplied pump, here pump is there, so what is the energy required to the supply pump, that will be reduced by this amount. Okay, which amount? By this amount. So in case for this condition, what is the energy supplied in by the pump, we can write energy, we can write energy supplied by pump, we can write this one, this equal to, actually what is the kinetic energy of this, like if the ship, if you consider, then we can write this is half mv square, inside here we can write half mv r square. Okay, relative velocity. And what about the velocity, what is the velocity of this jet which is coming in? So that is nothing but half mu square, because that is equal to, as I told you, the ship movement. This kind, the water which is coming inside, that velocity is equal to this one. So the kinetic energy what is there, same is here. So I can write half mu square. So from here I can write like half, you can take common, sorry, half m you can take common, and this is vr square minus u square we can write. So this is one point. Another point is the power supplied by the pump. Okay, the power which is supplied by the pump, that should overcome the losses. Okay, that should overcome the losses which is created here. So again, here also we need to find out the output of the pump. The output of the pump. Okay, this one we can write the energy supplied by the pump. We can say this equal to this energy supplied by the pump, the same thing what I've written. Okay, the total energy required equal to the kinetic energy of the pump and power required to overcome the losses. So energy supplied by the pump is nothing but the kinetic energy of this, so that is nothing but half. We can write, slight different is there compared to the previous one, only here one more terminology added here, like this one, plus the losses in the sense the power required to overcome the losses. So that also again same thing, we can write this is W into HF, the same terminology will be there. So here also we can write this is half into, what is the value of M? M already we have calculated previously here, 10,000, or we can write this is 10 to the power 4. This is 10 to the power 4, bracket start, VR is nothing but 7.5 square minus u square. U square is nothing but 5 square. Okay, plus what is the value of W? W also we have calculated, that is 98,100, and into this is HF is nothing but 2.8. The same here, what is the terminology is there. So this terminology will get the same value here, how much we got here, only this one we need to calculate. Now we can calculate this value we need to calculate actually. So what I'll do, I'll make it 0, and 7.5 square minus 5 square is 25. So 31 point into 10,000. 10,000 divided by 2. 156 250 250. 156 250 plus the previous term what was there, same term will be there again. Okay, so this is the terminology here. Now what I'll do, I'll just add the both of the things, plus 274680 430, we got 930, 430 930. So let me write down here, this is 430 930, and this is nothing but Newton meter per second, or we can write this is watt. If you want to convert again kilowatt, we can convert into 430 930 this much kilowatt. Now again we need to find out the power required for this. Again same conditions will apply here, like the input required. So let me write input of pump is calculated from, we can write same thing, efficiency of this equal to output by input here. So here we can again write input equal to, here input of the pump, we can write output by efficiency. Output equal to how much? This is 430.930 divided by 0.75. So this is nothing but, if you solve it, we can get input of pump equal to how much we got. Let's solve this. Okay, divided by 1000, again divided by 0.75, 574.57. So we got here 574.57 7 something we got this much kilowatt. Okay, this is the input of the pump. So this is nothing but so power required to drive the pump. This one we can write power required to drive the pump, which is equal to input of the pump. Here also you can write this is input of pump equal to, we can write this is 570.7 something is there kilowatt. Now you can see this is one condition power required and this is another condition power required. Okay, this is for when the water enters at the side. When the water enters at the side, in this side it is entering, but this power required when the water enters at this side. So that's why I have taken these two conditions in the same problem to identify how much power required to drive the pump or to drive the ship actually. Okay, I hope you understand this problem. Slightly lengthy, but you can easily understand, but we need to consider a few extra terminology here, like energy supplied and what is the output and efficiency terminology, we know that. And before that we need to find out this force equation. We need to utilize this force equation to find out like the mass value. Okay, because diameter is not given, so we cannot able to calculate the area. So from this we can calculate the mass, and from that we can calculate the W. Then once you calculate the weight value, then we can go for the output of this. I hope you understand this problem. Still, if you're having any doubt and query regarding this, you can give a comment on the comment box. Thank you.